Good afternoon, guys. Welcome to another session of Trans Communication. Today we are going to start with the sheet 5, random process. Sheet 5 is random process. So the given thing is that the random process for the random variable x uh, has the uniform distribution over 0 to 2. Find v of t or v of t1 comma t2 v square of t for the random process. V of t equals to v of t is equals to 6e power xt. Okay, this is a given thing. This let us take as f1. So the given thing is v of t equals to 6e power x. Okay, so here v of t is nothing but function. Okay, so the x is the random variable. X is random variable. Okay, uh, so t is the time with respect to time. So you have to find the mean. Okay, v this is v bar of rv of t1 comma t2 v square of t. Okay, so how to calculate the mean? Okay, v bar of t is nothing but mean. To find the mean, we have to find the expected value of x. Expected value of v of t is nothing v of t bar. Okay, so expected value of v of t is nothing but, so this we're gonna do v bar of t equals to half. It is not half, it is upper limit minus limit. It is 2 minus 0 from 0 to 2, 6 or x. So we can find it as 2 by 6 by 2, 0 to e power xt d x. X is the random variable, okay, dt. So here it will be 6 by 2, nothing but 3 e power xt by t from 0 to 2. Let us substitute the limit e power 2t e power 0t is nothing but e power 0 is 1 by t, which is equals to 3 by t power 2t minus 1. This is the mean v bar of t. Same way, we will find the autocorrelation function rv of t1 comma t2. So autocorrelation function is given as rv of t1 comma t2, okay, for two different times t1 and t2. So this is written as expected value of v of t1 and v of t2, v of t1 and t2. So expected value, what is v of t? V of t is nothing but 6 e power xt. With t1 it will be 6 e power x t1 into 6 e power x t2. Okay, so it will be 36 expected value of e power x t1 plus t2. Okay, so now when we remove expectation here, it will be like integration limit minus lower limit 0 to 2 lower limit x t1 plus t2 dx. So when we solve the integration here, it will be 18 e power x t1 plus t2 by t plus t2 from 0 to. So let us write it like it will be 18 by t1 plus t2 e power 2 t1 plus t2 minus e power 0 is 1. So this is the autocorrelation function. Okay. So same way we'll do the variance. We do for the variance, it is nothing but v square of t whole bar. So it will be v square. So r v of t comma t. Okay. So t comma t is nothing but expected value of v of t to v of t. Same thing. Okay. So here we'll write expected value of v of t1 e power x t into e power x t. So same thing. So it will be 36, 6 into 6, 36. 36, 1 by 2. Let us expected value of e power 2xt, right? So it will be like 36, 1 by 2, 0 to 2 power 2xt dx. It will be 18 e power 2xt by 2t from 0 to 2. I can write it as e by 2t e power 4t and e power 0, which is equals to e power 4t minus 1. Okay. So here it is same thing. Uh, this is like when you go here, when you substitute t1 equal to 2 equal to t, you will get the same thing. Okay. So you can do this way or you can solve in these steps. So here we complete question number 1. So question number 2 is the random variable x has a uniform distribution over 0 to 2 same limit. V of t is rv of t1 comma 2 and v square of t. Okay. So same thing we have to find here. So first thing, so we have to find v bar of t, which is equal to expected value of v of t, which is equals to expected value of 6 cosine x t. It will be 6, 1 by 2, 0 to 2 cosine x t dx. So we have to do integration with respect to x. It will be cosine x t. Sorry, we have to do the integration. We cannot write the same. So it will be the integration of cos is sine xt by t from 0 to 2. The limit may be changed, okay? It is not only 0 to 2 every time. 3 by t sine 2t and sine 0. Sine 0 is 0. So it will be 3 by t sine 2t. So here we find the mean for trigonometric function also, okay? Next thing, rv of t1 comma t2, it is autocorrelation function, which is equals to expected value of v of t1 into v of t2, which is equals to expected value 6 cosine t1, 6 cosine x t2, 36 expected value of cosine x t1, cosine x t2. So this thing is a trigonometric function which is being multiplied here. So we cannot do the integration of trigonometric multiplication function of trigonometric multiplication of trigonometric function. So what we have to do, we have to make this term in terms of sum this multiplication in terms of sum. How we can change from sum? Uh, we have a relation cos C cos D, which is equals to cos C minus D cos, sorry, plus cos C plus D. This is the relation. So we can write it as 36 expected value of cosine x t1 minus t2 plus cosine x t1 plus t2. So this is, we have converted this multiplication, okay, product in terms of sum. So 36 1 by 2 0 to 2, we will remove the x value here. Cosine x t1 minus t2 plus cosine x t1 plus t2 dx. Let us find the integration here. Simple. It is 18. So the cosine will be sine x t1 minus 2 by t1 minus t2. Okay. So cosine, sorry, sine x t1 plus t2 by t1 plus t2. 0 to 18 by sine 2 t1 minus t2, and sine 0 is 0, by t1 minus 2 plus sine 2 t1 plus t2 by t1 plus t2. This is the final answer. So let us move to the variance. V square of t bar is RV of t comma t, which is equal to expected value of V of t into V of t. So this is nothing but V of t into V of t is nothing but V of t into V of t is nothing but expected value of 6 cosine x t1, 6 cosine x t2. Okay, here it will be value of we can write 636 expected value of cosine square x. Oh, sorry, it is not t1 here. It is t only, right? Because function is the same function here, comma cosine t and cosine t. And this will be also t. So here it will be cosine, just cosine square xt. Okay, so how we can write cosine square xt? So we can write it as 36 expected value. So you cannot do the integration for multiplication function. Okay, cos square into cos into cos. So we have to make it in terms of sum form. It will be 1 minus cos 2xt by 2. Okay, so it will be 36 by 2 expected value of 1 minus cosine 2xt. It will be 18 1 by 2 0 to 2 1 minus cosine 2xt d dx. Okay, so just solve the simple integration. It will be 9. So integration of 1 is x minus sine 2xt by 2t from 0 to 2. So it will be 9. 2 minus 0 is 2 minus sine 4t by 2t. So this is your integration, and this is your variance, how we find the variance for trigonometric function. The same way we can find the variance for exponential function also. So if the random process x has a uniform distribution over 0 to 3 v of t, let us solve this. Sorry. Okay, the random process x has a uniform distribution over 0 to 3, find so and so. Okay, so what we have here, v of t is equals to 2 e power xt, 2 e power xt minus 2. Okay, so we have to find the mean variance and autocorrelation function here. So v of t is equals to 2 e power of xt minus 2. So what is mean? Mean is equals to v of t. V bar of t is nothing but expected value of v of t, expected value of 2 e power xt minus 2. Okay, so I can write 2 common outside, expected value of e power 2t minus 1. So this is 2. Okay, 1 by 2, 0 to 3 e power 1 by 3, 0 to 2t minus 1 dx, because here you have a limit from 0 to 3, right? Limit is given as 0x less than or equal to 3. So 0 to 3 is your limit. So here we'll write it as 1 by 3. Okay, the correction here 1 by 3. So it will be 2 by 3. It is 2 by 3 e power 2t minus 1. Okay, we'll do the integration. So it is 1 by 3 e power 2t, integration of e power 2t is e power 2t by it is 2, it is sorry xt, not 2t, it is xt. So we are differentiating with respect to x, so it will be 1 xt minus 1 into x from 0 to 3. Okay, so it will be, it is xt. Okay, 2 by 3 e power 3t minus e power 0 is 1 by t minus 3. Okay, so you can, if you want, you can solve further. 2 e power 3t minus 1 minus 3t by 3t. Okay, this is the final answer. This is where you find the mean for exponential. Okay, so next thing is RV of t1 comma t2, which is equals to expected value of v of t1 into v of t2, which is equals to expected value of, sorry, write it as expected value of 2 e power 2 x t1 minus 2 2 e power x 2t minus 2. Okay, if I take 2 common outside, it will be 4. Expected value of e power x t1 minus 1 e power x t2 minus 1 Okay, so let us multiply this. It will be 4 e power x t1 plus t2. Okay, e power x t1 e power x t2 plus 1. So let us, this is expected value here. So let us write it as 4. Let us remove the expectation and just directly write the limit. 1 by 3, 0 to 3 e power x t1 plus t2 minus e power x t1 e power x t2 plus 1 dx. So integrate it 4 by 3 e power x t1 plus t2 by t1 plus t2. The first part e power of t1 by t1 e power x t2 by t2 and integration of 1 is x from 0 to 2. Sorry, 0 to 3. You're just habituated of adding to 0 to 3. So it is 4 by 3 e power 3 t1 plus t2 by t1 plus t2 e power minus, sorry, t1 plus t2 limit, okay, minus 1 e power 0 is 1 e power 3 t1 minus 1 by t1 e power 3 t2 minus 1 by t2 plus 3. So this is what you are left with. If you want, you can solve further or you can stop here. This is the autocorrelation function. Mean square value, how we find mean square value? Mean square value is v square of t. Mean square is expected value of v of t into v of t. So expected value of 2 e power xt minus 2 into 2 e power xt minus 2. It will be 4 expected value of e power xt minus 1 e power xt minus 1. It will be 4 1 by 3 0 to 3 e power xt minus 1 into e power, sorry, you can just try the square here, okay? Before the writing this, we will write it in terms of square. So it will be 4 expected value of e power 2 xt e power xt e power xt plus 1. It will be 4 expected value of e power of 4, 2xt 2xt minus 2 e power of xt plus 1. So it will be like 1 by 2, sorry, 1 by 3, 0 to 3 e power 2xt minus 2 e power xt plus 1 dx. So it will be 4 by 3 e power 2xt by 2t 2 e power x 2 e power xt by t plus x 0 to 3. All mathematics brother. E power 6t minus 1 by 3t e power 2 e power 3t minus 1 by t plus 3. So this way you solve for the trigonometric functions. So today we have solved the random process for the normal function, trigonometric function, and the exponential function. So here we complete our random process for one random process. Okay. Here only the x was the random process. Okay. The next section we will solve the mean way. We will solve the same thing for the two random process. Okay, which depends upon each other. It was single random process, and next class we will solve x. Suppose x and y be the two independent random variables. Okay. So if you have any doubts, you can write them course message, or you can email me. Thanks for watching the video.